Hello everyone, in this video I'm going to share the solutions of IBHL Mathematics Paper 1 question from this year May. It is time zone 3, which is for Asia and Pacific countries. Last time I posted the video from time zone 1 and time zone 2, and I hope it was also helpful for you guys. And make sure to pause the video before watching and try to solve all of the question, and if you need help, please make comment on the comment section and have fun. Let's start by the question 1. Question 1, let log base 10 of 2 equal p and log base 10 of 3 equal q. Find an expression for log base 10 of 24 in terms of p and q. Find an expression for log base 3 of 8 in terms of p and q. First, let's check for log base 10 of 24, and if you factorize 24, you will see that it will be 2 to the power of 3 times 3. And from the attribute of the logarithm, you can write log base 2 to the power of 3 plus log base 10 of 3. From here, the other attribute of the logarithm, you can take the power into the logarithm, in front of the logarithm. Here, and you can write 3 times log base 10 of 2 plus log base 10 of 3. So we know that what is log base 10 of 2 is p, and the log base 10 of 3 is q, 3p plus q. At the question B, it asks for log base 3 of 8. From here, you can use the attribute of changing base, since it's the given in the question that 10, the base is 10, so we will replace 3 by 10 and write log base 10 of 8 over log base 10 of 3. We found in the previous question that log base 10 of 8 it is 3p, and log base 10 of 3 is q. So the answer is 3p over q. Question 2. The following diagram shows the graph of f of x between -6 and 5. This is the domain, right? So, and it asks for f of -3. So we're gonna go to the graph and draw a vertical line from which passed throughout the x-axis from the -3, and the intercept with the graph this point, and we are looking for this point of y coordinates of this point. So this is -1. At the question B, state the domain of inverse of f, and I know that the range of f, it is between -3 and 5, right? -3 and 5. So when you write the inverse of f, the range will be domain. So your domain is the x is between -3 and 5, you can write. Find the value of x that satisfies this equation, and again, if there is inverse of f of 2x minus 7 equals -3, it means f of -3 equals 2x minus 7, and we know that this from the a, there is equality in here, and we will find 2x is gonna be 7 minus 1, and 2x equals 6, x equals 3, right? Yeah. Question 3, solve the equation 2 times cosine 2 theta minus 5 times cosine theta plus 2 equals 0, where theta between pi and 2 pi. Let's remember the double angle formula, and cosine 2 theta equal, you can write in terms of cosine theta, is gonna be 2 times cosine square theta minus 1. We're gonna substitute in here 2 times cosine theta square minus 1 minus 5 times cosine theta plus 2. And when we simplify this expression here, 4 times cosine theta square minus 2 minus 5 times cosine theta plus 2 equals 0, right? So you can write 4 times cosine theta square minus 5 cosine theta, and 2 cancel each other. And cosine theta is a common factor of this expression. And in parentheses, you can write 4 times cosine theta minus 5. So I know that when you look at in parentheses and equal it to the 0, you will see that cosine theta gonna be 5 over 4, but It's not possible because cosine theta between -1 and 1. So I'm cancel this solution, right? And cosine theta will be 0 in this case because other factor is cosine theta. Where cosine is 0, I know that theta needs to be pi over 2. Don't forget to add, this is a periodic function, and you're going to write plus 2k pi. And theta can be either minus pi over 2 plus 2k pi, because in the first region and the last region at the fourth region, the cosine of these angles are equal each other. It means cosine theta equal cosine minus theta. That's why we're writing both equation. But from here, I know that theta between pi and 2 pi, there's no solution from the first equation, but when you choose k equal 1, it will be, theta will be minus pi over 2 plus 2 pi, which is 3 pi over 2, right? Question 4. Consider the curve y equals x squared minus x minus 1 and the line y equals mx minus 3 where m is a real number. Show that the curve and the line meet when x squared minus m plus 1x plus 2 equals 0. To do that, we're going to make equality between this curve and the line. X squared minus x minus 1 equals mx minus 3. Let's subtract the expression from the both sides, which is mx minus 3. X squared minus x minus 1 minus mx plus 3 equals 0, right? X squared in the common factor in x here, minus 6 in parentheses you can write m plus 1 plus 2 because 3 minus 1 is 2. So we find the expression in here. At the question B, hence find the values of m when the line is tangent to the curve. We will check this equation if there is one, if it is the line is tangent to the curve, there is one solution of this equation, right? Which means delta equals 0, discriminant is equals 0. So what is delta? It is square of minus m plus 1 minus 4 times the leading coefficient times the constant in here, c, it will be 0. From here you can write m squared plus 2m plus 1 minus 8 equals 0. M squared plus 2m minus 7 equals 0. Again, we need delta to find the roots of this equation. When we apply delta again into this equation, you will find 2 squared minus 4 times 1, because leading coefficient 1 in here, and the constant minus 7, which is 4 plus 28, and delta equal 32. From here you can write m1 equal minus 2 plus square root of 32 over 2. This is the coefficient of m2, and this one is 2 times the leading coefficient. And the other root will be minus 2 minus square root of 32 over 2, right? When you simplify this expression in here, minus 2 plus 4 square root of 2 over 2 will be minus 1 plus 2 square root of 2. And the other root will be minus 1 minus 2 square root of 2. The random variables x and y are normally distributed with x and y. Find b such that probability greater than b and probability for y greater than 22. There's a formula in your formal booklet. You can check it over there. The z-score. It is the number in here, for example, b minus the mean of the, because for the normal distribution in parentheses it's written the mean and standard deviation, right? So the first one is mean. B minus 7 over alpha will equal to the, for this probability, 22 minus, and the mean of y, the normal distribution of y is 19. So I'm subtracting 19 over alpha. From here you can find b, because b minus 7 equal 3 and b equal 10, right? Question B, write down the approximate value of probability between 7 minus alpha and 7 plus alpha. Correct to two significant figures. So what this means, it's better to know the attribute of normal distribution, and because it's not written on the formal booklet, but when you check for the attribute of normal distribution on your book, an IB book, for example, this is Oxford book, and you will see that from the graph that if this here is the mean and the middle is mean, between mean plus one standard deviation and mean minus one standard deviation, the area of this region will be 68 percentage. So the probability which is asked for us, it is gonna be 68 percentage. You can write 0.68. Okay. Question C, given that alpha 3, calculate the approximate value of probability for y less than 22 correct to significant figures. It's asked for y, probability of y less than 22. So the mean for y, the normal distribution, is 19, which means it asks for one standard deviation after the mean. We are looking for the area, this region, the area of this region. And from the previous question, we found this area. Actually, this is the attribute of normal distribution. This is 68 percentage, which means the half of it, 35 percentage. This area is equal each other. And I know that the total area almost 100 percentage, and you can say that here is the half of this, the total area is gonna be 50 percentage, and when you add 50 percentage to the 34, you will see that the probability of this expression will be 0.84, right? Yeah. Question 6. Consider the function f. The graph of f has a local maximum at a local minimum at b, a vertical asymptote at x equals minus 1 over 2, and an oblique asymptote y equals 5x plus 5. This information and part of the graph of f is shown in the following diagram. On the following grid, sketch the graph of absolute value of f of x, clearly indicating any asymptote. So since it's gonna be the absolute value, it will not have any negative value of f of x. In this case, we're gonna reflect the negative part of f over the x-axis, and it will be, for example, if there is minus 5 over 2, and here the value, which was the local maximum, is gonna be local minimum somewhere in here. And also, we will also reflect the oblique asymptote, the part of this negative side, over x-axis, and it will go like this. So the absolute value of the function, by the way, vertical asymptote will not change, and the y-intercept, actually the right part of this function will not change. We just change the oblique asymptote. It will pass through like this, and the y-intercept was 15 over 2. It will be the same. Will go like this, and the other part will be the have the minimum value in here. It's gonna be here. Yeah, this is the right graph of absolute value of f, right? And the question B, on the following grid, sketch the graph of y equals 15 over f of x, clearly indicating an asymptotes and intercepts with the axis. So that is 15 over f of x. And let's start by uh, the vertical asymptote. The vertical asymptote means making zero of the denominator of f of x. For example, we can say that if f of x has a denominator and minus 1 over 2 will make 0, this expression. It can be like 2x plus 1, right? And the oblique asymptote means there's an expression 5x plus 5 out of this fraction. What else? We know that, and yeah, something like this. So when we write that the denominator, and also let's take it in here, yeah, you will see that this 2x plus 1 will be nominator. In this case, x equals minus 1 over 2 will be x-intercept for this function, right? So the x-intercept will be here. And what else? When we look for the horizontal asymptote, you will see that when x approaches to infinity and 15 over 5 f of x will approach to 0 because I know that x are increasing to the infinity at the denominator of this fraction. In this case, this expression will approach to 0. So our horizontal asymptote will be y equals 0, which means the graph will not pass through the x-axis. Function f of x, there's a local maximum and local minimum. We can write it respectively. These are the point. But when you write the reciprocal of f of x, it will be the opposite. It's gonna be the minimum point. The maximum will replace by minimum, and the minimum point will replace by maximum point because we are looking for the reciprocal, right? Which means if you substitute, for example, 0 into the function is 15 over f of 0, 15 over 2 equals 2. From the other side, 15 over f of minus 1 equal 15 over minus 5 over 2. It's gonna be minus 6. At the point 0, the function will pass through 2, and at the point minus 1, the function will pass through minus 6. The y coordinate will be minus 6 in here. And this gonna be the minimum point, and this one gonna be maximum point. Yeah. But I know that there is a horizontal asymptote, so it will not pass through the x-axis, but there is also a maximum point in here. In this case, the graph will continue like this. Yeah. Question 7. The curve x squared plus y to the power of 4 equal r to the power of 4, where x between 0 and r squared is shown in the following diagram. The region enclosed by the curve and the y-axis is rotated through 2 pi radians about the y-axis to form a solid of revolution. Find an expression for the volume of solid in the form a pi r to the power of p. If you look for the y-intercept of this relation, we're gonna substitute 0 with x. And there's an equation here, y to the power of 4 equal r to the power of 4. It means y can be either r or minus r, the y-intercept here. So the region enclosed by the curve and the y-axis is rotated throughout 2 pi radians about the y-axis. It's gonna rotate throughout 2 pi radians. The radius of the solid will be the x coordinates of this points, right? And we can find the volume of the solid by using integral. And since we are rotating in the y-axis, and we can write the relation in terms of y, which is gonna be x squared equal r to the power of 4 minus y to the power of 4. And when you write the integral, and there's a pi out of the integral, and the limits is from minus r to r. We already gonna write the relation and square of this relation, which is in terms of y, and there's in here square of x. It's like a function which is written in terms of y, because the volume of the integral, when you check, if you rotated it about the x-axis, it was the square of the function, but here our relation is written in the y in terms of y. So this is almost same. R to the power of 4 minus y to the power of 4. Yes. What is the integral of this expression? The first one, r to the power of 4, we will just add y. And the second one, the integral of this one, y to the power of 5 over 5. And the limits minus r and r. Again, we're gonna replace r with a.
Uh, we're gonna replace r with y. So it's gonna be first pi times r to the power of 4 minus r to the power of 5 over 5 minus when you replace minus r with y, it will be minus r times r to the power of 4 minus minus r to the power of 5 over 5. Let's simplify and combine the like terms. R to the power of 5 minus r to the power of 5 over 5 minus in parentheses, or you can just distribute this negative sign into the parentheses. It's going to be r to the power of 5 minus r to the power of 5 over 5. And when you write the common denominator, multiple of this numbers is 5. In parentheses, you can write 5 times r to the power of 5 minus r to the power of 5 plus 5 times r to the power of 5 minus r to the power of 5 over 5 is gonna be pi times in parentheses, or you can just write 8 times r to the power of 5 over 5, right? Yeah. Question 8. Consider the complex numbers at 1 equals square root of 3 minus 3i expressed at 1 in the form r times e to the power of I theta, where r is greater than 0 and theta is between minus pi and pi. We know that at 1 equals square root of 3 minus 3i, and this is at the fourth region. If we call the horizontal axis the real axis and the vertical one is imaginary, the real part of this complex number square root of 3 and imaginary part is minus 3. We are looking for the argument of this complex number, which is the angle. So tangent, we can say tangent theta is going to be minus 3 over square root of 3. It equals minus square root of 3. And I know that theta will be pi over 3, but minus pi over 3, because tangent pi over t is square root of 3. How about the model, the radius of this complex number? It is gonna be square root of 3 square plus minus 3 square. It equals square root of 3 plus 9 equals square root of 12, which is 2 times square root of 3. We can write the Z1 in the Euler form. I know that this is the Euler form. And we found R, it is 2 times square root of 3 e to the power of I times minus pi over 3, right? Yeah. At the question B, consider the complex number Z2 equals 2 times square root of 3 times e to the power of I times 5 pi over 6. The cube roots of Z2 over Z1 are denoted by U, V, and W. Find U, V, and W. And we're gonna look for Z2 divided by Z1, and Z2 equals 2 times square root of 3 times e to the power of I times 5 pi over 6. And Z1 we found in the previous question 2 times square root of 3 times e to the power of I times minus pi over 3. And 2 times square root of 3 will cancel. E to the power of I times 5 pi over 6 minus, and there's also a negative sign in front of the pi over 2. It's going to be positive sign. And you can write pi over 2, 2 pi over 6. In this case, it will be e to the power of 7 pi over 6. Keep in mind that theta between minus pi and pi. So we are looking for the cube roots of this number. To find the roots of this complex number, do not forget to add 2k pi to the number, because as far as k is changing, you can find the roots of this complex number. And you're gonna apply by applying the Moore rule, we can find the roots, the cube roots, right? So e to the power of 7 pi over 18, because we are dividing the all of the angle by 3, plus 2k pi over 3. Let's say k equals 0, and you're gonna find the first root. Let's call it u, for k equals 0. U equals e to the power of 7 pi over 18. For k equal minus 1, because I know that the theta will be mm, between minus pi and pi. That's why I'm giving minus 1. And we is gonna be e to the power of 7 pi over 18 minus 2 pi over 3. But when you find the common multiple of these two numbers, it will be 18, and we're gonna multiply the second fraction by 6. And the complex number will be e to the power of minus 5 pi over 18. For, let's say, k equals minus 2, and I will find the last root w, e to the power of 7 pi over 18. And when you replace k by minus 2, it will be minus 4 pi over 3. And the number will be, oh, we forgot I, right? Yeah, I, there is I in here, I in here, in here. Yeah. So pi times 7 pi, or let's check it. We will multiply it 6, and it will be minus 17 pi over 18. Yeah. Question 9. Determine the value of limit as x approach 0 for x times sin x divided by 1 minus cosine x. When you plug in 0, you will see that 0 times sine 0 divided by 1 minus cosine 0. So the numerator is 0 and the denominator is 1 minus 1, because I know that cosine 0 is 0. It will be 0 divided by 0. We don't know this. It can be 5, 6. And we're going to apply, in this case, the L'Hopital rule. Therefore, we can apply L'Hopital rule, right? So limit x as approach 0 for, let's find that what is the L'Hopital rule. We're gonna find the derivative of numerator and denominator. First, let's find the derivative of this expression. It will be, we're gonna use the product rule, and the derivative of x is 1. In this case, 1 times sine x plus x times derivative of sine is cosine, right? So derivative of this denominator will be 0 plus sine x, because I know that the derivative of cosine is minus sine. And when you replace x with 0, you will also see that 0 plus 0 divided by 0 plus 0. Again, there is 0 divided by 0, so we can uh, apply the L'Hopital rule again. Hospitals rule again. We're gonna check limit as x approach 0 for, now we're gonna find the derivative of this expression first. The derivative of sine is cosine, and when you use the product rule in here, you will find cosine x minus x times sine x, because the derivative of cosine is minus sine. At the denominator, the derivative of sine will be cosine x, right? From here, you can say when you substitute x with 0, you can write limit is as x approach to 0, and plug in 0 here, cosine 0 plus cosine 0 minus 0 times sine 0 over cosine 0. Limit as x approach 0, cosine 0 is 1, and divided by 1, it equals 2, right? Yeah. Question 10. Consider the sequence un with n term given by un. The first three terms are u1 equals k minus 5, u2 equals 3 minus 2k, and u3 equals 5k plus 3. K is a real number. Consider the case when un is an arithmetic. Find the value of k. Yeah. So if this is an arithmetic sequence, and there is a common difference between uh, these consecutive numbers, in this case, we can write the common distance is, let's call it d, and it's gonna be u2 minus u1, and also equal u3 minus u2. u2 is 3 minus 2k, minus u1 is k minus 5, equals u3 is 5k plus 3 minus u2 plus 3 minus 2k. From here we can write 3 minus 2k minus k plus 5 equals 5k plus 3 minus 3 plus 2k. If we combine like terms, we're gonna find 8 minus 3k equals 7k, 3 will cancel. And if we add 3k to the both side, it's gonna be 7k plus 3k. It's 10k equals 8. K is gonna be 8 divided by 10, which is 4 over 5, right? Yeah. And the second question, hence or otherwise find U3. We find the key. To find U3, we will just substitute 4 over 5, and U3 is 5k plus 3. 5k plus 3. 5 times k is 4 over 5 plus 3. 5 cancel. U3 equals 7. Question B, consider the case where k equals 12. Show that the first three terms of un form a geometric sequence. And k equals 12. So we're gonna plug in 12 for k. U1 equals k minus 5, and k equals 12. In this case, it will be 12 minus 5 equals 7. U2 equals 3 minus 2k. When we plug in 7 for k, or 12, sorry, it will be 3 minus 2 times 12. 3 minus 24 equals minus 21. And U3 equals 5k plus 3. 5 times 12 plus 3 equals 63. Yeah, this is the first three terms of UN. B1. At the question B2, given that UN is a geometric state, a reason why the sum of an infinite number of terms of the sequence does not exist. Let's check for the common ratio. What's common ratio? It is also U2 divided by U1, and you can find from U3 divided U2. These are consecutive terms. From here, you can find the common ratio. And I know that U2 is minus 21 and U1 is 7. Likewise, and 63, which is U3, and U2 is minus 21. From here, you can see that this ratio will equal to minus 3. It is the ratio of this geometric sequence. Since absolute value of minus 3, which is ratio, is greater than 1, uh, we can say that the geometric sequence does not or is not convergence. Yeah, it is convergent, right? Yeah. And the other question is the sequence UN is geometric for a second value of k. Show that k squared minus 10k minus 24 equal 0. Yeah, in same manner, we're gonna find u2 over u1 equals u3 over u2. And we don't know that in this equation the k, so we will write u2 in terms of k, which is 3 minus 2k, over u1, it is k minus 5, and u3 is 5k plus 3 over u2 is 3 minus 2k. From here, we can find an equation. When we make cross product, we're gonna see 3 minus 2k squared equals 5k plus 3 times k minus 5, and the left side is gonna be 4k squared minus 12k plus 9, right? The complete square of this expression. And when you apply the distribution here, you're gonna find 5k squared minus 25k plus 3k minus 15. We will again combine like terms, especially the right side. 5k squared minus 22, let's say k minus 15, right? And now I'm gonna subtract 4k squared from the both side, and it will be minus 12k plus 9 equals k squared minus 22k. minus 15. And again, I will add 12k to the both side and subtract 9 from the both side. So it will be the left side will be 0 and the right side will be k squared minus 10k minus 24, right? Yeah. So we found this expression in here. The other question, find the first three terms of un for the second value of k. Let's find the first three terms. U1 is k minus 5. By the way, we're going to find the second k from here. And for this, you can factorize this quadratic equation. It will be k minus 12 and 2, because when you make cross product, you will see that some of these numbers gonna be minus 10k. So the factors of this quadratic will be k minus 12 times k plus 2 equals 0. From here, you can see that k either 12 or minus 2. We used minus 2 before, or which one? Yeah, we used 12, and we're gonna use now the second value of k is minus 2. From here, k1, k2 you can write. U1 will be k minus 5, k minus 5, minus 2 minus 5 is minus 7, and u2 will be 3 minus 2k, 3 minus 2k. It will be 3 minus 2 times minus 2, 7. And u3 is u3 5k plus 3, 5k plus 3, 5 times minus 2 plus 3 is also minus 7, right? Yeah, we found the first three terms. And hence write down the value of S2m, the sum of the first two m terms for the second value of k. From here, you can see that, for example, the first term is minus 7, and the second term is 7, and the third term is minus 7, and the fourth term will be 7 also. So when you add these numbers, it's gonna be 0, right? If that is even terms in here. In this case, you can, since 2m is even number, right? As 2m equal 0, you can say, yeah. Question 11. The points A, B, C, D form a parallelogram A, B, C, D, where D is a diagonally opposite B. Find the coordinates of D. So if you look for this parallelogram and D is diagonally opposite of B, you can just place D and B in here, and A and C. This is gonna be the parallelogram. I know the points A, 1, minus 4, 0, and the point B is minus 3, minus 6, 2, and 2, right? And the point C, minus 1, minus 2, 4. Yeah. So there's a midpoint in here. If you draw the diagonal of the parallelogram, you will see that this is the midpoint. Actually, at the second question, it asks for that, right? The diagonals of the parallelogram AC and BD, which is in here, intersect at point E, find the coordinates of E. So for the first question and for the second question, you can actually do the same. Especially for the second question, we can find E, which is gonna be the midpoint of A and C. In this case, you can write 1 plus minus 1 divided by 2, or the y coordinates of this point is minus 4 plus minus 2 divided by 2, and the z coordinates of this point is 0 plus 4 divided by 2. So the point is 0, minus 3, and 2. Yeah. Uh, you can also use this point for the question A. Uh, you can do the same. It's okay. From here, you're gonna say that the point D, if you call it x, y, z, in this case, x gonna be minus 3 plus x. Sorry, 0 will be, which is the x coordinate of E, the midpoint, minus 3 plus x over 2, and the y coordinate of E is minus 3, equals minus 6, which is y coordinate of B, and the y coordinate of D is y over 2. And the z coordinate is going to be 2 equals 2 plus z, over 2, you can say. From here, you can see the point D will be, right, 3 from this equation, and the point Y will be 0 from this equation, and the point Z will be 2. Yeah, 302 point D. At the question C, given that AB cross product AD equals m times this vector, where m is a positive integer number, find the value of m. So how we are finding the cross product? There is also formula in this formal booklet. You can check over there, right? I'm gonna take this from the formal booklet, the formula in here. I will take it, and we will use the other formal, two formals, to find, for example, the area of the parallelogram. And yeah, just take it this here. So our vectors is AB and AD. Let's find first AB. AB, right? Yeah. I put it A and B in here. So AB vector will be minus 4. The y coordinate, you know that from the y coordinate of B, you're gonna subtract the y coordinate of A. It's gonna be minus 6 plus 4 minus 2. And for the z coordinate, you will do the same. The z coordinate of B is 2 and the z coordinate of A is 0. When you subtract it, it's gonna be 2, right? And AD is, in same manner, you can apply the same. And we find D in here. 3 minus 1 is 2. 0 minus 4, it's gonna be 4. 2, right? Yeah. And when you apply this formula in here, the cross product, you're gonna see that. So it will be uh, minus 2 times 2 minus 2 times 4 at the second row. It's gonna be 2 times W1 is gonna be 2 minus V1 is minus 4 times 2. At the last row, V1 is minus 4 times W2 is gonna be W2 is 4 minus V2 is gonna be minus 2 times W1 is gonna be 2, right? Yeah. So when you simplify this expression in here, you will see that minus 4, minus 8, minus 12, 4 plus 8, 12, and minus 16 plus 4, minus 12. Yeah. So the number of m is the number of m. It's gonna be in here. You can say that m is 12, right? Yeah, as you can see in here. Please find the area of parallelogram. This was the C1. And C2 is gonna be, let's say, the area of the parallelogram. This formula in here, we found actually was that this the cross product of these two vectors, and we found another vector in here. So it will be the area, the magnitude of this vector, which is gonna be a square root of 12 square plus 12 square plus 12 square, right? And from here you can see that this will be 12 square root of 3. Yeah. Uh, The plane pi1 contains the parallelogram ABCD. Find the Cartesian equation of pi1. Let's say there is a plane in here. We call it pi1. Pi1, right? Yeah. And this parallelogram inside of this plane, we know that this the parallelogram, and we know that the vector AB and the vector AD, and we found the cross product of these two vectors, and I know that this cross product, it will give us the vertical vector to these two vectors, which is normal of this plane, right? So we can say the normal of this plane is the vector that we found in here, minus 12, 12, and minus 12. Yeah. If we know the normal of this two, this plane, so we can write the equation of this plane like minus 12x plus 12y minus 12z equal, let's say, d. And how we're gonna find d, for example, you can just plug in this point into this plane equation. For example, let's say I know the point A. A uh, is here. 1 minus 4 and 0. And when you plug in this point into this equation, you will find minus 12 times 1 plus 12 times minus 4 minus 12 times 0 equal d. And from here, minus 12 minus 48 equal d. D equals minus 60. And again, when you want to write the equation of this plane, and we also find d and divide all of the sides by minus 12, you will find x minus y plus z equal 5, right? Yeah, this is the equation of the plane. And a second plane, pi 2, has Cartesian equation in here. As you see, the acute angle between pi 1 and pi 2 is theta. Show that cosine theta equals 1 over 5. So how are we going to find the angle between two planes? For sure, we're going to use the normal vectors. And I know that the normal vector of pi 1 is, let's call it m1 equals minus 12, 12, and minus 12. And n2, we can say the normal vector of the second plane, 5, 1, minus 7, right? 5, 5, 1, minus 7. For example, if you want to write the scalar product of these two vectors, it's going to be n1 product n2 equal model n1 and model n2 times cosine theta. We already going to look for cosine theta, or first, let's say theta. And the scalar product of these two vectors will be, I'm just multiplying these dimensions of two vectors, minus 16 plus 12 plus 84 equal the model of m1. You can say we already found it in the previous question, 12 square root of 3 times the model of this vector, 25, 1, 49. I just square of these all numbers, and cosine theta. Just simplify this side, 36 equal 12 times square root of 3 square root of 75. From here, you can cancel 12, and 3 equals square root of 3 times 5 times square root of 3 cosine theta. Cosine theta equals, you can cancel 3 also, 1 over 5, right? Add the question F. I'm gonna add the other page in here. Other page. Yeah. Hmm. The line L passes through E and is perpendicular to pi 1. The line L intersects the plane pi 2 at point F. Find the coordinates of F. So let's draw this first. There is pi 1, I know this already, and the parallelogram inside of this, and the point E is intersection of this diagonal, and we know that the point A is in here, 0 minus 3, 2, and L is passed through this point. It is perpendicular to the plane pi 1, and it is passed through the point F, which is on the plane pi 2. We will find the point F, right? Yeah. So we can write the line equation in here, and I know that this is the direction of this line is the same with the normal of pi 1. We know that the pi 1 direction is m1 is in here, minus 12, 12 minus 12. If you would like to write that, let's call it L, the equation of L, and I know that this the point is on the line, so we can use that one in this case. X, Y, Z equals 0 minus 3, 12 plus lambda times. By the way, I will uh, write, since the minus 12 is the common factor of these all numbers, I will not use minus 12 and divide it all of these dimensions to minus 12. So it will be 1, minus 1, and 1. We will just plug in this or first find x equals from here. You can write lambda y equals minus 3 minus lambda, right, from this equation, and z equals 2 plus lambda. We will just plug in these points into the pi 2 plane equation because I know that equation 2 is given in the question in here. Mm, this one, right? Yeah. Mm-hmm. And I will just plug in this xyz into this equation. 5 lambda plus, or let's say minus 3 minus lambda minus 7 times 2 plus lambda equal 1. We will just simplify this all of and combine like terms. For example, in here we can write 4 lambda minus 3, and when you distribute this minus 7, it's going to be minus 14 minus 7 lambda equal 1, and minus 3 lambda minus 17 equal 1, minus 3 lambda you can say 18, and lambda equals minus 6, right? In this case, we found the point of, let's say, f because it will give us these coordinates. Mm, And the x coordinates of f will be lambda, which is minus 6, y coordinates minus 3 plus 6, and the other one 2 minus 6. So you can say f equals minus 6, 3 minus 4, right? Yeah. You can just write like this. Question 12. Consider the complex number z equals x plus yi, where xy is a real number such that modulo of z minus 2 plus I equals 3. Show that x squared plus y squared minus 4x minus 2y minus 4 equals 0. Z equals x plus yi, and I know that the model of this complex number is 3. So what is this complex number inside this model? When we write z, x plus yi minus 2 minus I, and when you combine the real part and the imaginary part of this complex number, you can write x minus 2 plus I times in parentheses y minus 1, right? Yeah. And the model of this complex number is 3. So how are we going to find the model of this complex number? In parentheses, we will write the square of the real part plus square of the imaginary part, right? This is gonna be 3. It means x minus 2 square plus y minus 1 square equals 9, right? And square of x minus 2 is x squared minus 4x plus 4 plus y squared minus 2y plus 1 equal 9. And again, combine the like terms or simplify this expression, we can write x squared plus y squared minus 4x minus 2y plus 5, but when you subtract 9, it's gonna be minus 4. We found, right? Yeah. And the argument of z plus p over z minus 1 is pi over 4. P is a real number. Show that this expression in here. So what's going to be z plus p and z minus 1 divided by z minus 1. Let's check it first. And we know that z is x plus yi plus p divided by x plus yi minus 1. When you write the real part of the complex number of the numerator, x plus p, and the imaginary part is yi, at the denominator, x minus 1 plus y. So to divide these both complex numbers, we're gonna multiply it both up and down with the conjugate of this denominator, right? It is x minus 1 minus yi. I will multiply it with both sides. Yeah. So it will take a bit time. At the numerator, just be careful. X squared, I'm just distributing, right? Minus x, x, y, I, and again with px minus p minus py, I. And I'm gonna multiply yi with the terms in parentheses again. Yix minus yi is gonna be plus y square because I square is minus 1 and minus y square is gonna be plus y square. So at the denominator, it will be x minus 1 square plus y square. Again, these are conjugate, as you can see. So just simplify the denominator especially, or numerator, and x, y, cancel. You can write x square plus y square for these terms, and minus x, and this one plus px minus p minus pyi minus yi. Yeah. And what's given in the question that mm, the argument the argument of this complex number is pi over 4, which means tangent pi over 4. I know that it's 1, so I'm gonna use this. And since, by the way, what's the real part of this complex numbers? To do that, I will just write the real part first. It's gonna be x squared plus y squared minus x plus px minus p over this one, the denominator, plus let's say I times you can write and denominator will not change, and I times, let's say, minus py minus y. So to find tangent, right? Tangent pi over 4, I know that this is 1, which means you're gonna divide the imaginary part of the complex number to the real part. So the denominator will cancel. I will just write this the numerator minus py minus y divided by the numerator of the real part, x squared plus y squared minus 6 plus px minus p. So when you make cross product, or you can say just x plus y squared minus 6 plus px minus p equals minus py minus y, and collect all of the terms to the left side, x squared plus y squared plus px minus 6 minus p plus py plus y equals 0. So it means x squared plus y squared x times in parentheses p minus 1 plus y in parentheses p plus 1 minus p equals 0, right? Yeah, this is the equation that we need to show. Yeah, yeah. The other question is two rules of the equation. This equation are Z1 and Z2. Both Z1 and Z2 satisfy the conditions. As you can see in here, the model is 3, and the real part and the imaginary part is equal each other. Use the result from parts A and B to find Z1 and Z2. So what we find that the question A, if there is a model like this equals 3, we are finding this equation. Okay. At the question B, we found that, for example, the argument of this expression is pi over 4, which means tangent pi over 4 equal 1, and it is also give us that the real part of this, for example, complex number and the imaginary part of this complex number equal each other. As you can see at the question, it's already given. So we can apply this rule which we use in the question A in this question too. It means if, let's say, from here you can write P is 4, because to use this expression or this condition in the question A, it's we need this condition too. The real part and imaginary part of the complex number need to be equal each other. because of this, P need to be 4. So when we plug in for P in here or in this equation here, and we can write x squared plus y squared plus 3x plus 5y minus 4 equals 0. At the question A, we also use the other equation, this one, x squared plus y squared minus 4x minus 2y and minus 4 equals 0, right? So when we use this equation in here and equal each other, you will find that, or you can subtract, right? You will find 7x plus 7y equals 0 because these cancel. In this case, it means x equals minus y or y equals minus x. So when you replace y with minus x, for example, in the equation, the first equation, you will find x squared plus x squared because we replace y with minus x plus 3x minus 5x minus 4 equals 0, right? From here, you can write 2x squared minus 2x minus 4 equals 0, which means when you divided the equation by 2, you will find x squared minus x minus 2 equals 0. I'm going to factorize this, x minus 2 and 1. Just make sure that when you cross product and add this expression in here, you're going to find minus x. So you can write this factors x minus 2 times x plus 1 equals 0, which means x either equal 2 or x equals minus 1. Yeah. From here, you can find, let's say, Z1 can be uh, Z1 is gonna be, we say, yeah, Z1 because our complex numbers in the form like x plus yi. So if the x is 2, it means y is gonna be minus 2, and Z1 can be 2 minus 2i, and Z2 if x is minus 1, and the imaginary part of this number will be plus I, right? Yeah, we found Z1 and Z2. At the last question, found the value of alpha, right? And I know that this part of this equation will give us the sum of all of the rows, right? What was the sum of all of the rows? Z1, Z2, Z3, Z4 is gonna be minus alpha over 1 because the leading coefficient in this equation is 1. From here you can write uh, and just be careful that all of the coefficient of this equation is a real number. So the sum of this all complex numbers need to be real number, which means, for example, Z3 need to be conjugate of Z1, and Z4 can be conjugate of Z2, right? From here, you can say that Z3 will be 2 plus 2i, and Z4 can be minus 1 minus I. But when you add all of the roots, you will find that because imaginary parts cancel, and you will just add the real parts, it will be 2. If minus a is 2, a means minus 2, mean minus 2. Yeah.
Yeah, we saw all of the questions of paper 1 time zone 3 from this year May. Since the graphic calculating and TI is not allowed in this paper, it requires really good computation and procedural skills. Just make sure that do the questions, all of the questions, try to solve by yourself before watching the video, and share the video with your friends who are also preparing for the exam or just want to learn these topics. And see you in another videos. Take care. Bye bye.